Hello everybody, today I'm going to talk about turtle graphic and I'm going to implement it in SDL. And I decided not to continue to show how I'm doing things in virtual machine because there is not too much difference I'm guessing it's going to have, but I will have more comfortable environment for myself for implementing things, debugging, because I will have my own configuration for Emacs and so on and so on. So what is turtle graphics? It's basically the way to draw things, and it's not based on coordinates and based on some very simple set of commands. So we have a turtle, and turtle can walk forward or backward, and you can turn turtle left or on right on certain degree. So let's first me explain you how I'm going to implement this thing. So we have some coordinate system, and let's say we have turtle on the center of coordinate system, and turtle actually points this direction, and we want to make turtle to move like this direction forward by like let's say 100 pixels on this direction. So it points this way, and it means it has some angle here, right? And this line is 100 pixels, and just basically we want to know the coordinate of this point, and so this is x coordinate, right? And this one is y coordinate. So what is x and what is y? And if we know simple trigonometry, so simple trigonometry means like this thing is going to be, if I'm not mistaken, cosine of angle alpha multiplied by 100 pixels. So basically 100 pixels multiplied by cosine. And this thing, am I right? No, I'm wrong. Right, so it's 100 pixels multiplied by sine, and like I want to know this thing, and this thing is 100 pixels multiplied by cosine of alpha. Basically that's it. This is a whole trigonometry what we need to know, and we are going to implement our turtle like this. So that's it. Enough drawing things, and let's go for developing, implementing things. And first of all, I'm going to implement very simple SDL thing. So let's have lab, and let's make the directory turtle.cpp. So we are going to have class turtle, and yeah, I did not explain you about classes and things. Probably I'll do this thing on the way. So class basically, like before we had variables, right? Like int x can have so x is type int, right? Or we could have like string str, like str is type of string, and x basically has can have integer values inside, and str can have text inside. So class is basically we are describing user defined type, and it can have different values inside, like integer and some value, right? And let's have float x, float y. So it can have coordinates inside. We can of course do it like separately, float x and y, right? And it's fine, but combining things, it's easier because we can have describe some operations between with these two values, right? Like we have some operations with variables float, like we can add things or subtract things, and here's it. We can just move turtle forward and it's would change x and y in parallel, like not like separately but together. So for turtle we have variable x and y and also angle. I can probably make it a, right? And we have some operations with turtle, like we can say turtle to move forward. So we call it method, but basically it's functions which are applying to this particular class. So it's member functions. Forward and left, so this is angle, and right, this is angle also. And I think it's enough operations we have, and we can implement it here. So this is syntaxes for member functions. So you have to provide the name of the class, then 2 colons, and name of function. So here is it. For left and right, basically we need to change angle by value, and that's it. So turning left, it's actually turning left, it's going to be minus, and the reason is coordinate system in computer is in SDL, if to be precise, is different than in math. Like y points to down in computer in SDL, then in math it points up, and x is like as in math like points right. So because of this thing, then we're turning left, we need to subtract value, and then we're turning right, we need to add value. And for forward, I'm going to calculate new x, and new x is going to be old x plus cosine, right? Value multiply by cosine angle, and angle, I want to use angle in degrees, and cosine here takes angle as in radians, and convert degree to radian. It's very simple because in radians 360 degrees equal to pi. So what I need to do, I need to divide by 360 and multiply by 2 pi. Ow. Let me double check, is it correct value of pi or not? So it says 314 15 5, right? So this is correct value of pi. So this is for x, and for y it's sine, right? Now I need to draw the line, like let's pretend I'm drawing a line here, and here I'm going to assign new x and y to new y. And for drawing line, because I do not remember, I need to go to SDL2 and see how it's implemented. SDL2. SDL render draw line x, y, and z. So x, new x, wait, xy, new x, new y. So, and let's allow our turtle to have window and all these other things. So I'm going to encapsulate all SDL functionality also in Turtle, and basically right now implementation of Turtle is finished, and everything else it's just wrapper around SDL. So in Constructor, like, yeah, so I need to explain what is Constructor. And Constructor, it's function, member function, which are going which is running automatically. Then you are declaring variable of type, your class type. So turtle 2, and I'm going to initialize SDL equals 0. Here's it. I'm going to throw exception. Basically, yeah, we didn't talk about exceptions, but this is the way to raise some errors. And before we just were actually I can return here too. Let me throw exception. And we have a set of standard exceptions. So I'm going to throw runtime error, and I just going to copy and paste the thing. So now I'm going to create window, and it's going to be 180 by 720. So we discussed this thing last tutorial, and this thing I'm going to put here. So it's SDL window, SDL. So also destructor it's function which calls automatically, then variable is destroyed, like use of variable is ending. So in destructor I'm going to do cleaning. So I run cleaning, and yeah, so here's it. I want to set the window on coordinates 6, and you know, I need to add some functions like clear and like flush. So clear is going to clean whole screen, and flush is going to flash all drawings to the screen. So I'm going to implement here clear, and clear is going to be, and flash is going to be, oops, and like this. I think it's good enough. So I'm going to start writing main function, and here I'm going to have turtle, and then clear flash, and here I'm going to put delay SDL for 2 seconds. I have my tool, automatic tool, which is doing building. Oh, so I need to include SDL SDL2, and then float. Else I need std accept SDL destroy render. I think it's like this. SDL destroy renderer, SDL destroy. That's it. Let me run it and see what's going on. Yeah, we got black screen, and you know I want white screen, so I like to put color in clear. Yeah, set color, set renderer, throw color, set. So white color is FF, and 0x means the value is hexadecimal. Let's make it simple for you. It's like 255, 255, 255. So color represents an SDL with 3 components, red, green and blue, and first component is red, like how much is it, and maximum value is 255. Second one is green, third one is blue, and then if you're mixing all 3 colors, red, green and blue, you're getting white. So if you're mixing, for instance, red and green, you will get yellow, right? If you're mixing red and blue, you will get purple, and so on. So different types of mixing, you will get different colors. So right now we are going to use white, and all zeros means black. And yeah, last component, it's alpha component, transparency, and I do not remember what I supposed to put. I think I supposed to put non-transparency means 255, something like this. I do not remember. I always confused. So we get white screen, and also I need to initialize these values. So here I want to put 180 divided by 2. So I'm going to put on the center 720 divided by 2, and angle is 0. So let's move by 100 and see forward and see, would we see line from center to right? No, we didn't see line from center to right. What did I do wrong? Yeah, here is it. This is Y. That's it. So bug should be fixed. Yeah, here is it. And let's draw the square. So to draw square, I need to go forward, turn left by 90 degrees, and repeat it 4 times. Here is it. We got square. It's slightly not squarish, and I think the reason is because I'm using float. We can upgrade to double just to make it simple for you. Of course, we could use like better techniques. And I'm going to remove also all F from here. I think we're good now. Let's check it out. It's still not squarish enough. I'm wondering why. Yeah, anyways, I think it's fine. I'm wondering why. Let's draw more things, and so we made the square, and also we can make star. And to do this thing, we need to move like we need to do things like this: 2 to 5, and we need to iterate 9 times here. So we can have star here. Here's it. We can do slightly more more things around star, like 38 for instance, but we need to have sharper angle, 175 for instance, and we can get this kind of star. Also we can have more shallow star, so we can have like 20 here and put 95 here, like this. And we can do like a lot of interesting things. Also we can add some colors or draw the circle, you know, like let's say polygon. We can draw a polygon, and like let's say again, let's go back from 4, right? So this is our square, and we can have pentagon. So for pentagon it's going to be 5, and basically what I need to do, 360 divide by 5, and so this is going to be pentagon. And I can have some constant here, like const auto number of sides and I can make 6 here. Oh yeah. So here is it 6, and let's make it crazy 60, and we get basically circle, but it's too big, we cannot see it. We can make it smaller. Here is it. So this is Turtle graphics. Thank you for watching. It's very simple, and you can do it by yourself in virtual machine, or you can set up your own C++ environment. Thank you for watching, and hopefully see you next time. Bye.